and then we'll talk about what's going to come next. Gracie? Sure. And number 28. Oops. It's a weird place to decide to put that. Okay. So this says a plane can travel at 600 miles per hour under its own power. If it travels on a bearing of 200 degrees and there's a 50 mile per hour wind on a bearing of 80 degrees, what is the plane's actual speed and bearing? Jason, did you check in at the office? Yeah. Okay. Thank you. So when I read this, I read two vectors. So the first vector is that plane. So its magnitude is 600 miles per hour, and its direction is that 200 degree bearing. So I'm going to start by translating that direction into an angle of rotation. So a bearing begins at due north. So there's 90, 180, and then 20 more. So my angle of rotation is going to be 90, 90, and then 70 more. How do I know that's 70? Yeah, it's the complement of 20, exactly right. So my angle of rotation then is 250 degrees. So my second vector is this wind. So its magnitude is 50, and its bearing is 80 degrees. Again, I'm going to translate that bearing into an angle of rotation. And that one's super easy. The angle of rotation there is just 10. Okay with that? Okay. So I'm going to go ahead and resolve vector 1 into components. The x component is going to be 600 times cosine of 250. And the y component is going to be 600 sine 250. Similarly for vector 2, the x coordinate is going to be 50 cosine 10. And the y component is going to be 50 sine 10. And then my resulting vector is going to just be v1 plus v2. So the x component for that vector is the sum of the x components. And the y component for that vector is going to just be the sum of the y components. Okay with that so far, Gracie? Oh, that happens. So if we type this into our calculator, make sure that we're in degree mode, since we're using degrees. And I get about negative 155.97. And then if I do the other one, I get about negative 555.13. So my new speed is just going to be the same as my magnitude, which is just going to be using the Pythagorean theorem on those two values. And when I do that, I get about 576.63. So the wind slowed me down a touch. Okay, there. And the last thing I need to do is calculate a bearing. So the first thing I'm going to do is draw my new vector. So I go 155 to the left and 555 down. So my new vector is somewhere here. And my bearing then is going to be this angle. So that's 90, 90. And then this spot is going to be the complement of that phi that we've been using before. Right? This is phi, which in this case is going to be tangent inverse of the absolute value of Vy over Vx. Elizabeth? So I plotted the point negative 155, comma, negative 555. So that those x and y components are like a point. They tell me the location of that resultant vector. Does that feel okay? Okay. All right. So I do that. And I get 195 for my bearing. Oops. So there's my speed. And that's as a bearing. I think is probably how what they asked for. Yeah, was a bearing. Is that okay? Okay. Looks like a lot of people are still writing things down and punching things through their calculators, which is good. I'll pause here just for a second before we take the next question. I think, Kristen, you had your hand up also right in the beginning. We'll go to you next. But we'll just pause for a second here. It looked like a couple of people were still finishing up writing things, but we're probably about ready for you. I've tap danced here enough. Okay. They're basically the same kinds of problems. Sure. Yep. Okay. Gilligan is steering the minnow. He leaves a tropic port at a bearing of 108 degrees at a speed of 35 knots for 2 hours. So V1 is got a 70 for its magnitude and a bearing of 108. So 108 is like 90 and then 18 more. That makes this side 72. So my angle of rotation is going to be 270 plus 72. So that's 342. Okay. Then he turns at a bearing of 286 at a speed of 45 knots for 2 hours. So 45 times 2 is 90, so that's my new magnitude. And my bearing was 286. So starting at north, 90, 180, 270, and then like 16 more gets me there. So my angle of rotation is here. So that's 90, and then the complement of 16 is 74. So 90 and 74 gives me 164. So far, so good, Kristen? Okay. Now we'll just resolve each of these into component form. So V1x is going to be 70 cosine of 342. V1y is going to be 70 sine 342. V2x is going to be 90 cosine 164. And V2y is going to be 90 cosine, sine 164. And then if I know those, I know that my resultant vector is just V1 plus V2. So Vx is going to be V1x plus V2x. And Vy is going to be V1y plus V2y. So let's go ahead and do those now. I've written out enough. That's about negative 21.77. Oops. I'm going to adjust that because I made a typo when I pressed the button in the calculator. So that first number should be a little bit more, negative 19.94, excuse me. Okay with that? Okay. So my magnitude, or my new speed, or I guess it's distance in this case, right, is just going to be the square root of Vx squared plus Vy squared. So when I type that through my calculator, I get about 93.53. And then if I draw this to figure out the direction, I go negative 19 to the left and then 90. So this is going to be my location. So that's my bearing. So it's going to be 90 plus 90 plus 90 plus that angle phi that we calculate before. So my bearing is 270 plus tan inverse of the absolute value Vy over Vx. Oh my goodness, people. I made a boo-boo. Nothing in the work that I've done, just in me pressing things into the calculator. I need to backtrack just a skosh. This number here should be 3.18. Oopsie-daisies. I'm sorry, guys. At least I caught it, though, right? You know what I'm saying? Or no, you're mad still? I get it. I'd be mad, too. Hey, listen, settle down. People make mistakes. You're going to have to yell at me like that. I'm trying hard, I promise. It's just, it's like first thing in the morning, you know? Everybody makes mistakes. Happened to me. So our distance is 20.19 nautical miles and our bearing is 279.05. Does that feel okay, Kristen? That's plus tan inverse of the absolute value of Vy over Vx. And it'll always be tan inverse of the absolute value of Vy over Vx. It'll just be whether you're adding or kind of subtracting that from some quadrantal amount. You're welcome. What do you guys think? Yo, Josh. Let's see.
I'm pretty sure I did all the math to this week, so the direction.
Okay, so this is the same idea, right? We just have three vectors, right? And you feel comfortable that you added the three vectors correctly. Okay, so just give me that result.
Adding the vectors, I got the x, so 6.5.
Okay.
And the y,
Okay. So I'm just going to assume that those are correct and show you how to do the bearing from there. Sound good? Okay. Because this becomes a length, you know, like, it's like 10 minutes of like writing stuff down. You get it. You did the problem already. To ask just about the end part, if you understand the first part. And it's really the same process that we just did for the previous one. So I'm not, you know, in a too big of a rush. So that's where it's located, right? We go 6 over and 2 up, so we're there in the first quadrant. The bearing is this distance. What we're going to be able to find is this distance, which is or that angle, which is our phi. So up here, this is going to be 90 minus phi, right? Because it's got to be its complement. So that's how I'm going to do the bearing. So 90 minus tan inverse of the absolute value of Vy over Vx. And that's it. Does that feel okay?
Yeah.
Okay. So again, it's very similar to what we were doing in worksheet 2. Where the picture really kind of helps us enormously and we're just kind of counting. Again, one of the reasons why I tried to approach the problems in worksheet 2 the way I did is because it scales very nicely. Like it almost doesn't matter whether you're talking about a bearing or an angle of rotation. You kind of do it the same way all the time. You just figure out what that angle of phi is and then add it or subtract it depending on where it's at from some multiple of 90, and you're basically done. That's okay, Josh?
Yeah, I must have put it into my calculator.
Well, it's the mode also could be an issue depending on what you were recently doing. If your calculator's in radian mode.
Yeah, it could have been. I got like 0.4.
Yeah, that's probably what happened is you were in radian mode. I bet if I take that number, that 70.07, and multiply it by pi over 180, I bet I get like 0.4-ish. Nope, I get 1.2. Yeah, if you could have, it's possible if you flipped them, or something, you know, like that'll screw things up too.
I think I'm just trying to put in like one for the first factor.
Oh, maybe. If you had flipped the x and y, like if you'd done vx over vy and been in radian mode, you would have gotten a much smaller number. So that's definitely possible of how you got the 0.4 or whatever, or got some little teeny tiny number. Yeah, of course. Jason? 4? Sure. Or at least we'll get her started here. So we have 3 things going on, right? So basically we're just going to be adding 3 vectors. Is that okay with that idea? Okay. So the first vector, we have a bearing of 61, which means our angle of rotation is 29. That's okay there. So our v1x is going to be 16 cosine 29. And our v1y is going to be 16 sine 29. Our next one, we have a bearing of 43. So our angle of rotation there is going to be 47. So v2x is going to be 6 cosine 47. And v2y is going to be 6 sine 47. And then the last one, we have this bearing of 217. So 90, 180, and then 37 more gets us to here. So our angle of rotation is going to be 90, 90, and then the complement of 37 is 53. So 233 is our angle of rotation. So v3x is going to be 3 cosine 233. And the y is going to be 3 sine 233. So to find our vx, we're going to do v1x plus v2x plus v3x. That gives us about 20.85. Our Vy is just going to be V1y plus V2y plus V3y. That gives us about 13.32. So our speed then is going to be the square root of Vx squared plus Vy squared. So that's about 24.74. I think those were knots. And then our direction, we're 20 over and 13 up, so we're in the first quadrant. So we're looking for this bearing. This is our phi, so our bearing is going to be 90 minus phi. So 90 minus tan inverse of Vy over Vx. That comes out to be about 57.43. Is that okay, Jason? So they're all pretty similar, right? Once you kind of get the hang of the procedure, whether you're doing 1 vector, 3 vectors, or 10 vectors, they're all kind of work the same, which is nice, right? Like it gets a little bit, I mean, there's more, it gets more tedious with more vectors, but like the general procedure just stays the same, which is lovely that it scales so nicely. It doesn't get much more complicated. It gets a little bit more tedious, but the steps are basically still the same. Anybody else from this? Cool. What I need for you guys to do next, then, if you don't have your tablet out already, I'd like you to take your tablet out. We're going to do our homework quiz here. I think you guys probably had a feeling this was coming, as that we haven't had one yet this chapter, and we're almost at the end. So if you didn't know it was coming today, well, you should have known it was coming. So if you open your tablet and go to our shared notebook and find the content library, you'll see inside the content library the homework quiz here. So you can move this into your notebook, do the homework quiz, export that file as a PDF, and then there's an assignment on PowerSchool called Homework Quiz 4 that you'll turn this into. Make sure you turn it in there and not to the test. When you finish with that, you can take the remainder of your time in class to work on any math homework you might have, or to be honest with you, if you're quiet and non-disruptive, I wouldn't even notice if you weren't working on your math homework, if you had something else that was higher priority right this moment to work on. But I know that you guys all probably have math homework that you could be working on, so you should find something to do. It's not, oh, you know what? Oops and mid-oopsies. Hold on a second. I was in 4th hour's notebook when I did this, so I'm going to cut this page that we just did for notes, and I got to go into 5th hour, and maybe I haven't moved it into the content library for 5th hours yet. Yup, I haven't done that yet, so let me paste this guy in, and then we'll go and grab this guy. And then we'll go back to the content library. We'll paste him in. And then we'll sync this notebook. So if you guys sync yours in a minute or two, you should see that kind of pop through. I'm glad you guys noticed and said something. I would have been completely clueless and just sat there going, why can't you see it? Why aren't you doing anything?